Greetings. As promised, this video will cover the first activity in the science fair workshops. This activity is called the mystery box. And these are the supplies you will have for the mystery box. You will have mystery boxes, which are Chinese takeout containers because they're cheap and easy to open and reclose. You will have items that might be in the mystery box, and you'll have these in a bag just full of a bunch of the items, but you will also have them in these reference bags, which contains one of each of the 6 objects that could be in the mystery box, being a plastic toy, a wooden peg, a copper penny, a steel washer, a steel paper clip, and I feel like I'm missing something here, and a ball of foil. And a ball of aluminum foil. You will also have this worksheet that the students will use. You'll have some masking tape. You will have these lovely jewelry scales. And you will have magnets. These are all your supplies. So what you will do, usually when you get to the classroom, you will prepare the mystery boxes. So we have enough scales to have 9 groups in each classroom. So students do need to work in groups. Usually they'll be in groups of 2 to 4 kids, depending on the size of your classroom. Just make sure there's no more than 9 groups. And then you want to prepare the mystery boxes, basically out of the mystery bag. You take an object, whatever it is, you throw it in the box, you hook it together, and then you take a little bit of the masking tape to seal it down so it doesn't fly open when the kids are shaking it, because they're going to shake it a lot. So make at least 9 of these, but probably make a couple of extras because many kids will finish quicker than others, and so you can give them a second box to distract them while you're waiting for the rest of the kids to finish. So the point of this activity is to use the scientific method that we just introduced in the workshop. And so this worksheet actually has all the steps of the scientific method built into it for doing this activity. Now the first one, ask a question. Well, we already have that. The question is, what's in the mystery box? So we're going to try to answer that. So after you explain all of this to them, you will then give them this worksheet, a mystery box, an open reference box with each of the objects in a reference baggie. And this is for them to do their background information and their hypothesizing. So looking over the reference objects and shaking the box, they should write down some things that they notice. They don't have to go crazy on this, just like, it sounds round, it sounds kind of big. When we were looking at our reference objects, we thought, it was similar to this. So then they can hypothesize. Well, that's where my other magnet went. Then they hypothesize, and they can say, like, we're pretty sure it's X, or they can say, we're pretty sure it's either X or Y, or we're pretty sure it's not HIJK. Whatever they've got just based on what they've got before them. Then the most important part is they need to write down their experimental procedure. So they're going to have 3 tools available to them. Don't give them their tools before they write their experimental procedure, but do show them the tools. So they have themselves, their own senses, their hearing, their touch, their feeling of things. They also have the jewelry scales and a magnet. So given the 3 tools that we're going to provide them, they need to write a procedure to try and figure out how to test what's in their mystery box. And on the back side here, they actually have a little pre-made data table where they can write the name of the test and what the results were for each object. And this is to clue them in that whatever test they do, they should not just do the mystery box, but also to the reference objects, and not just to one reference object, but to all reference objects. This is particularly important because there are 4 metal items in this bag, but only 2 of them are actually magnetic, and sometimes kids don't know that some metals are not magnetic. They just think that all metals are magnetic, so they should test every object for magnetism. But you try to let them work this out and nudge them gently that way. So once they've written down their procedure, and the littler kids are less likely to write this out really detailed, but as long as they can explain it to you and it's reasonably coherent, then you give them their scale and their magnet and let them test. If a group gets done early, like I said before, give them another box, and then just go around and help them. Then when most or all of the groups have what they think is an answer, we go around and we do the reveal. Now there are a couple of details and logistics for passing out the supplies. Don't give them the scale and the magnet till they have a plan. Some of them will think they have the answer just from the shake test, and that's fine, but encourage them to go ahead and get multiple confirmations of their hypothesis. The more data we can collect as scientists, the more certain we can be of our conclusions. So the scales, when you hand them out, these are really great, easy to use little scales, but one thing you do need to do is put them on a hard surface and turn them on, and don't move them until the display reads 0.0. If you move it while it's still calibrating, you'll get an error. If you get an error, just turn it off, set it down on a hard surface, turn it on again. The kids will want to grab these the instant you set them down. Don't let them until it's zeroed out, and explain to them, like, if it's 0.0, then you're fine, but if it says error or something weird, then they need to turn it off, turn it back on again, and not move it. They really love playing with these scales, which is fine. Magnets, pretty easy, just don't pinch yourself, which there's nothing here. If they only have one magnet, they can't really do that. But again, encourage them to magnet everything. They can use their table to write down their results. And how they go about using the scale will be different from different groups. Obviously they'll weigh the mystery box and, write down the weight of the mystery box. Some of them will weigh the objects individually and then weigh the reference box separate and want to do some math, addition, subtraction type of stuff. Others will just put the reference box on and put the object in and take the weight. That's probably the easiest way to do it, but they can do it however they want. Now there are a few little tricks in this activity. One, there's something different between these two boxes that is not the item that's in them. It's the tape. I don't tell the kids this, but some of them figure it out. They figure out, like, especially if they have a paper clip in their mystery box, they begin to realize really quickly that part of the weight differential is probably the tape. So if they ask you about this, or if they ask for tape, by all means, give them a section of tape that's about as long as the tape that's on here. That's great thinking. I love to encourage that. If nobody figures it out, you might want to point that out in the reveal. When they say, like, we couldn't get our weights quite the same, you can say, well, what's different between these two boxes? And then they'll all go like, oh, the tape. But they're smart. Usually someone figures it out. Another area where they can get tripped up are these balls of foil. They don't know this, but I did not weigh these balls of foil when we made them. We just tore off strips of foil and threw them in the bag. In fact, when we originally did this, they weren't wadded up in balls. They were in strips. The kids wadded them up. So you can see from this bag here, and if they look around at other people's reference objects, they may notice this. Some of the foil balls are very small, and some of them are quite large. And some of that has to do just how much they've been squished, but also they're different sizes. So the foil can be a really tricky one to figure out because it's not magnetic, it's kind of the same shape as the toy, and the weight can be highly variable. So that's a tricky bit about it that might throw them off, and that's okay. This isn't really about getting the right answer, it's about how to learning to use the process. So when pretty much everybody's done, we go around and do the reveal. And what I do is usually back and forth with my partner. We each do, I do one group, she does another group. We go over, we take their mystery box and we say, okay, so what did you test? What did you find out? And they'll usually say, like, we noticed it sounded really round. We thought it might be the toy, but it could also be the washer. So we decided to test it with the magnet. Okay, what happened? And they're like, no, the magnet didn't work. Okay, that's pretty good. What about the scale? I'm like, yeah, the scale, it weighed like this one with the ball in it in the reference box weighed pretty much the same as the mystery box, so we're pretty sure it's the toy. Okay, great. So then you open the box like so, and you hold it out just so they can see it, so they get to do the reveal, and you say like, okay, what was it? And they go like, yay, it was the toy, we got it right. And if they got it right, you say, hey, everybody, give them a round of applause, good job. Then you go to the next group. If a group got it wrong, which happens with the foil ball and the wooden peg a fair amount, let them know, like, hey, there's a trick about this foil ball. They don't all weigh the same, so, we made it hard for you. And let them know that, like, it's about the process, what they did. Like, your procedure was great. It was really a toss-up between whether it was the foil ball and the wooden peg, and it just so happened that your reference ball weighed the same as a wooden peg, or, something similar to that. And then everybody say, like, give them a round of applause. You guys did a good job. If anybody did any particularly creative thinking, make sure to, like, draw that out. Like, if a group asks for the tape, say, like, you guys did something different from the other groups. You want to tell me about that? And they're like, yeah, we noticed that, the weight was off a little bit, and we thought that it might be the tape, and then we weighed the tape, and this is what happened, and, that's great. There's frequently a group that does that. It's really good. And they're very surprisingly meticulous sometimes about recording their weight. Even though they don't know that it's in grams, they'll say pounds, but that's okay. And that's pretty much it. The hardest part about this is just doing the reveal, is getting everybody to sort of stay quiet and listen to one another. And sometimes you'll have a group that's finishing up their data collection while you're doing the reveal, and that's fine. Just ask them to try and keep it quiet. And so you may have to do a couple of the science rocks to get people's attention. But it's a really fun activity. They always do well at it, and I think it really brings home, what the point of the scientific method is. And even if they make mistakes, when they hear how other people did it, they realize like, oh, we should have done it that way, and that really helps them learn. So that's it. Thank you very much for watching, and on to the next video.